Okay, so this week we are going to talk about LLMs for code generation. So this is a big fat yes if you're Claude, if you're Anthropic, but they're trying to sell you a product. So of course they would say, in fact, Claude Code is probably the most utilized coding agent out there. So they would say, yeah, we don't need software engineers anymore. I think it's a bit of an exaggeration because someone's got to prompt the thing. Like the AI isn't going to prompt itself, I don't think. Maybe, but yeah, we'll see. Um, so it is the case that to actually produce code, you probably don't want to be doing it manually anymore. You want to use the LLM to at least do some of the low-level function writing. And this is why I'm doing this early, because for the rest of this course, I expect you to at least utilize some LLM-generated code for the apps that you build. But here's the kicker. I want you to be able to read that code the LLM is generating and be able to explain it to me. And I think that's where some people get caught because, like in the previous one, I could tell it's LLM generated, but like you just scroll right through it and then you don't explain it to me. And then to me, that's not really acceptable because I think LLM generated code, you can't just generate it and then run it and then not understand what it's doing. For me, I think it's essential when you use LLM code that you actually understand every line that it is sort of producing. You still have to be able to validate that. So, but you can see here, this is the human eval benchmark, and LLMs, and particular LLMs, they get way better than a standard human in producing code to reach these benchmarks. So why wouldn't you do that? Well, it turns out there are things that LLMs aren't very good at. So there are things like, well, if you send an LLM at, GitHub issues, it can't produce a fix for more than 5% of these things. So there is some higher level thought that needs to go around the use of LLMs for code generation. And that's why it's really important to me that when you do your screencasts, I am convinced that you understand all the code that's in your repository. And so producing less code is actually better if you can explain all of it to me. You had a question? It might be way bigger now. It probably solves more than 5% now. Yeah. So, but it's all a matter of scale, really. And so you're saying, well, where is the sweet spot? So for I would say for small amounts of code or small function call level things, it's 100% the right thing to use. But then when you're talking about how code interacts with each other and architectures and modularity, it's like, yeah, you could prompt an LLM to do that. In fact, that's what you're going to do. There's an architect mode where if you are really good at prompting, you can just with natural language get all of the modularity and interoperability and interfaces specified correctly for you to just completely use natural language to build your application. But for most of us who are just getting used to using an LLM, like this takes some practice. Like when you prompt the LLM the first couple of times, it's going to produce stuff that you just didn't expect. And then over time, you're going to get used to exactly what the LLM is going to require to produce the code that you really need. And this is the whole point of the homework this week. So you're going to be building one app, but you're going to be rehearsing a script to be able to generate that app deterministically through copying and pasting a bunch of prompts. So this is something where you could use different kinds of prompts to get your app running, but then you're going to create a very concise script that allows you to regenerate the whole thing in one shot using just natural language. And this process, this iterative process, because usually when you're going back and forth with the LLM, you're like, oh, maybe I need to do this add-on, or maybe I need to do this add-on because you're doing it as a chat. And interactively, the LLM is getting the sort of the context that it needs to figure out what you actually meant when you said, build me this application. So with that, I'm trying to get you to just generate the prompt up front that has everything the LLM needs to produce the code that you want. So this is an iterative practice for you to be able to learn how to best prompt a coding agent. So that's That's a preview of the homework. I don't want in this screencast to see you type any single line of code. You have to be rehearsing your prompts so that when you show me how you built your application, it's basically copying and pasting the prompts in your prompt file. And then because those prompts are so well rehearsed and so well specified, you deterministically generate me an app in 5 minutes that runs with just prompts. That's your goal this week, yeah.
How deterministic? How deterministic is it, and how do you want to demonstrate?
So when you do the prompts, there are ways of specifying exactly what you want, where the LLM will produce the exact code that you want. So that's basically, so I don't want you to implement a web browser in 5 minutes, but like you'll see, like, so the labs, this week, there's a lab of doing polymorphic ransomware. That's what you'll be doing. And you'll be rehearsing a script. I give you a script. And in fact, I'm gonna show you some scripts of what students did last time. And I give you some scripts, and then you can see not all of these scripts are good, actually. Some of these scripts, when you replay them, they'll give you errors because of what you didn't specify. And so this is where this week is you sort of getting you experience going through these prompts that allow you to more effectively produce code from a coding agent. That's the goal. That's the intended goal of this week, actually. Whether or not I think you'll get closer to this as we go along. So there are some cases. People who are super good at prompting can build entire applications via vibe. So the other term for this is vibe coding. So this flight simulator, someone built it. It makes $5,000 a month, and this was all done with Cursor. Oh no, 38,000 total. So after 10 days of being online. And it was just using this AI, the code builder. And you'll see all these different companies like Claude Code, and Google's got Anti-Gravity. They've all got these interfaces where you just, with no coding experience, you specify what you want in natural language, it produces the app for you. So that's the idea of this particular one. But so it's being used to produce good code, but it's also being used by adversaries to produce malicious code. So you'll be walking through the steps of doing this in your lab. Well, you'll be prompting the LLM to incrementally produce you Python malware. And then you'll see sort of the precursors to what these folks are doing. So this was just discovered a couple of weeks ago, this VoidLink malware. It's basically one of these advanced rootkits they discovered later, a week later after they went through this. They're like, this is most likely AI generated, LLM generated code. So that's where we're going. Okay, so one of the things that they found is that if you're gonna do this, if you're just gonna go straight vibe coding for your applications, you need some guidelines. And so I like this particular article from last summer. They looked at LLM produced code, and they're like 40% higher secret exposure in AI assisted code repositories. And then they looked at about a third of the AI generated database queries for SQL were vulnerable to injection. So the LLM might not, this is why it's really important, especially if you understand a little bit about security, that when you look at the code that gets generated, it has addressed some of these security issues. And I'll give you some examples of how you would want to prompt an LLM to make sure it's producing secure code. Okay, so some of the things that were observed in this particular study is that the AI is going to generate what you ask for, but not what you forget to ask for. So if you didn't ask for security, it's not going to implement it. This is why in this particular week's assignment, I should see security concerns in your prompt so that the AI generates code that protects your application from compromise. That's part of the rubric. I just added it actually, just to make sure that as you are vibe coding, you are actually specifically prompting the LLM to make sure this isn't vulnerable to like SQL injection. Like if your app has a database component, I better see that, make sure that this is using a secure form of database querying, like a parameterized query or a prepared statement, or make sure it does some filtering for injections. Like that needs to be in there in your prompts. So I'm trying to get you used to this up front so that when you go out there and you do try to vibe code things, at least it's going to be kind of secure. You're going to know about security before you ask the LLM to produce this code. The LLMs are trained to complete, not to protect. So it's trying to guess what you want. And if you didn't say, hey, implement security, you're not going to get it. It is trained on libraries that may be deprecated. So if it was several years old and it's using a library that has been shown to be vulnerable or been abandoned, it's going to show you that code. It's not going to tell you not to, well, some of them might tell you not to use it, but you are running the risk of having code that's out of date and is using insecure sort of modules. Vulnerable code is in the LLM's training data. So whether or not a model will give you that vulnerable piece is up to the model. And so there are plenty of, I'm going to show you some examples where you ask for something and it's just like, yeah, I'll produce something that seems to be what you're asking for, not what you should be asking for. Like, so those are two different things to an LLM. So yeah, LLMs will omit security unless explicitly prompted. So I'm going to give you an example. Build a login form for a web application. And the LLM's like, oh yeah, I'm going to use username and password, and I'm going to check if the password you get is equal to the expected password. And you'll be like, well, what's wrong with this? Well, the expected password is probably in plain text. And so you've got a completely insecure pattern, but this is, the LLM thinks it's doing its job, right? You didn't ask for it, so why not? So there are no rate limits. So if you took the web and cloud security class or are taking it, I'm covering CSRF next week. Actually, no, tomorrow, if you're in the web and cloud security class, there's no CSRF protection, there's no input validation, there's no insecure password storage. There is no constant time comparison of the passwords, which is a side channel problem. So yeah, you could ask, is like, I just need a password protected app, but it would give you this and not take care of any of that. And so this is what you would want, you as a prompter. So like, I need to produce code, but I have to specify all of this. Otherwise, it's not going to get implemented. So you have to know, this is why I don't think humans are going to be like omitted here in this process. You have to know to say, I need IP address rate limiting, for example. I need CSRF protection. So implement CSRF tokens. Do all of this stuff in order before you produce any code for me. So I'm hoping to see that in your screencast when you develop prompts, especially when you're handling untrusted input. You got to make sure that that thing is not going to hijack whatever application you've built. Okay, so then you're like, okay, so it probably implements all this, and then it uses a password hash, which is like in 491, 591. It's like, oh, this is a cryptographic. It's a password hashing mechanism that is basically a secure password hashing algorithm that resists dictionary attacks and all this other stuff. And that's what you get implemented in your app. So that's your end state. That's what you actually want to have implemented. And so this is why when you're developing your prompt script, like you're basically getting the best prompts that you've come up with to produce the code that's good, and you're saving it in that file. And then when it comes time to do your screencast, you're just replaying it. Okay. Here's another one, build a file upload server. And so the app's like, okay, well, if you don't say you shouldn't upload executable files, you shouldn't check for path traversal, it'll skip those things. So if you are in the web and cloud security class, this is a huge vulnerability. Like if someone uploads a PHP file and then you allow someone to execute that, they've got code execution immediately on your server, right? File path traversal. If you allow this and the adversary navigates to where your SSH keys are stored, they'll just overwrite that SSH key and then get immediate SSH access to your web server. So this is what you would need to prompt your LLM with. Build a file upload server. It only accepts image files, sanitizes file names, so it can't do file path traversal, stores the files outside of the web root so that they cannot corrupt the web server file system. You'd also want to say that, also the machine root as well. And this would be your prompt. You would actually explicitly enumerate the things that the file upload server should implement. And this is the kind of thing that I want you to be able to express in whatever script you're using to generate your application. Okay, so that article that I mentioned has these guidelines, which I think are pretty good. Set reasonable expectations based on experience. So how do you get this thing to be deterministic is one of the things that you'll come across. Well, you'll have to specify things in pretty good small increments that you trust that the LLM will be able to produce correct code with. And that's your building block for using LLMs to produce code. You have to be able to interact with the LLM in a way that you know you're going to get exactly the right result you're expecting from the prompt that you give it. And usually it's like if you have a prompt and you use it over and over again and you look at what the LLM is producing, it's pretty good. When you have really specified everything, it's pretty good at giving you the same result every time, or at least functionally implements the same result every single time. So that's setting reasonable expectations on the performance of the LLM. Understanding training cutoff dates. So if you know that the LLM stopped training 2 years ago and you're basically asking it to give you the most up-to-date LangChain code, you're going to have to rely on something else to get you the best LangChain code. So for that, then you also need to understand the context available to the model. So if you're using the model like we're using it, where it's just a black box and it's running on an inference engine on the Google backend, and it's not connected to any other MCP servers, and then you ask the model a question about the up-to-date LangChain, it's not going to give you the right result. So if you go to the web interface like ChatGPT or Gemini, it's using MCP tools to get the latest LangChain documentation in to be able to answer this question for you. So understanding which models are doing this and which models aren't is super important when you have this task of upgrading your code. Tell the model exactly what to do. So this is where you're specific on all the required features. And this is where you're going to need practice. So you're like, yeah, when I ask for this, it will 100% or at least 99% of the time give me what I'm expecting. And that's what I like as you're developing your script, that's what you'd want to go with. You'd want to repeat the prompt multiple times to make sure that it's always giving you the results you want. One of the things you can do is turn it into a conversation, at least initially. Before you can just hit a home run with the first prompt that you put in there, you might need to ask the model back and forth all of the things that it's just assuming you wanted because you didn't specify. So this is one way of being able to develop your prompts better, is to ask the LLM, well, for example, say you had a web application with a backend database and you asked the LLM to sort of implement it, and it implemented it, and then with the implementation, it'd be like, well, you should have specified what kind of database you wanted, because I'm just giving you SQLite 3, because that's what, if you didn't tell me to use SQLite 3, yeah, that's what I'm going to use. So that's the kind of thing that you can go back and forth with the LLM to really get the prompt specified so that everything is in that one prompt. That would kind of be the ultimate, is to build your application using one enormous prompt, where everything important is encoded in that first prompt. That's what you could do with this. Okay, if you in your prompts, you can include a couple of shots, few shot examples of the expected functionality. For example, you could give it unit tests. So I don't know, Andrew Tomac came into my office. He's like, LLMs are terrible at this particular regex thing that he was working on. And I was like, because it's like a custom thing. And he's like, maybe that's good so that my students don't rely on an LLM to do this homework. And I'm like, well, but give the LLM a chance, give it a couple of shots. And then 20 minutes later, he's like, yeah, the LLM implemented it. Given these few examples, just the examples of the regex input and the expected output of the match was enough for the LLM to infer the things that he didn't specify in his prompt. So I'm like, sometimes it's not the LLM, it's the person prompting it. And because he hadn't specified particular behaviors of his regex, The LLM couldn't figure it out, but then when he gave the examples that showed the kind of behavior he wanted, the LLM figured it out. So this is where this is helpful to give that model an example to work with, so it passes unit tests. You're basically giving it the unit tests in your prompt, and that would be something that's helpful for the LLM to implement what you're asking it to do effectively. So that's what this one is. So have the model generate the unit tests, and then to test the output with, as part of it. So this is so when we go to the coding agent, you can actually ask the coding agent to implement the unit tests and run them at the same time, and then go in a debug loop, fixing the code until it passes the unit tests. And then you can see it doing the entire debug loop that you used to have to do manually. That's what I'm hoping you at least see once with one of these things. And so these coding agents, they change all the time. So as part of this homework, I'm allowing you to use your favorite one, either Claude Code, Copilot, Anti-Gravity. They're in the lab. You're going to use Aider, which is a CLI coding agent. So you can use that one too if you'd like. Okay. So those are the basics. I'm gonna now, so in your lab, I'm gonna take you through a tour of some of the things that you can use an LLM for code generation, that's related to code generation. So I'm gonna start with the code reproduction lab. So as part of this lab, I'm gonna give you some source code, and then you're gonna have an LLM explain what that source code does. And then I'm going to have you prompt the LLM to say, well, what prompt would you give yourself to reproduce that code? So this helps you, like if you've never had to prompt, like I'm sure most of you have prompted an LLM to produce code, but if you ask the LLM, what is the best way to speak to you to produce this code? You'll be surprised at what the LLM produces that you wouldn't have up front. So this is where you're trying to get into the head of the LLM that's receiving a prompt to generate code, and that's what step number 2 is. And then you're just going to take that generated prompt and paste it back into the LLM to see, did it work? You told me this was the prompt that will allow you to generate that code exactly. See if it does. And then if it doesn't, this is where you have to go in there and modify the prompt so that it does give you exactly what you asked for. So this is an iterative process for you to get to know your LLM. And I would recommend not changing LLMs, the models, too much, because LLMs are different in their behaviors. So getting to know one model is, maybe they're all, I have no idea. I think they're similar in the way you interact with them, but who knows? This is why I'm having you do this. So this is I don't know. This is like opening up a can of worms every time I offer this. It's I don't know what people are actually going to do and whether or not it's going to work. Okay, so the program that we're going to start with is a very simple program. It's a password-based authentication program that's built insecurely. You're like, okay, LLM, well, as you copy and paste this into the LLM might be like, hey, this code is insecure. That's a win. That used to not happen, where the LLM was smart enough to say, you gave me a terrible implementation. It wouldn't judge you like that, but now it does. And it should, actually, because here's a simple username password authentication program. You see here, you have a users class. The constructor of the users class connects to a database file, a SQLite 3 database file, and the database is stored in users.db. If the database is empty, it basically initializes a set of users. And then this is what happens with the initialized users. You create the table. It's got 2 columns, username and password. They're both text fields, so you're storing the password in plain text. And so the exercise is going to be, can you do something about this implementation? And you see if the LLM actually does something reasonable with this implementation. And then you commit it, and then you add the user, admin password 123. So this is your starting point, completely insecure, but that's the point. And then you have a method called add user. You give me a username and a password, and then I will see if it exists first. And then if it doesn't exist, then I will create the row username password, and I will insert into this table the username password, and I'll commit this. So that adds a user. And then if I want to check the user, say someone's tried to log in and they've given me their username and they've given me their password, then what I'll do is I'll select the password from users for that username, and then I'll do a comparison. If this is equal, and if it's equal, I return true, you're authenticated. So completely insecure, but this is our starting code for the rest of the exercises. So the first one, I want you to ask an LLM to do unit test generation. So here's an example of a square root function, and you're like, okay, if this is a integer, then do the square root, otherwise raise the value error. So let's say that's the code, and you're like, give me unit tests. And then the LLM will happily produce these unit tests that checks to make sure this thing throws a value error if these parameters don't hold. So here's where, well, this tests that the square root of 0 is 0. If it's not an integer, you should be raising the value error. If it's a negative integer, you should be raising the value error. So this is all automatically produced. And you're going to ask the same thing for your database example. So here's an example. Create a unit test for that code that I just gave you, the username password code. And then it'll try and add a user, and then it will see if it exists after you added it, and then make sure that when it goes and finds that username, it is still there. The test user is there. So this is something that the LLM, you want the LLM to produce this so that you don't have to, because unit tests are pretty boring for developers to implement. So this is it's one of the many tasks that you would typically allow the LLM to do. Test the existing user that has been added. So you add admin and new password, and then check if the user is valid. Is again a unit test you could get the LLM to produce. Now, the LLM isn't going to produce an exhaustive list. And in fact, there might be some unit tests that you were thinking that it would produce that it didn't. And this is where you would have to reprompt it. You could actually give it some of the unit tests that you would like, or the kinds of unit tests that you want, and then it would produce something that's more aligned to what you wanted. Okay, the next thing that you might want to use an LLM for is to do type annotation. So before Python 3.6, Python was completely dynamically typed, and there was no ability to specify the data types of any of the variables in the language. Now, if you are a programming language person, this is terrible for security and reliability and understandability. You do want to do some kind of type checking to catch errors. This is the whole reason like Rust and these sort of like type-safe languages have been developed. And so you've got all your cruddy Python, pre-Python 3.6 code, and you're like, maybe I should do some type annotation for this. But you don't want to do it yourself. So then the idea is like, I'm going to just pass the LLM this code and say, generate the type hints for this particular code. And then this is what it'll do. It'll know that because you imported SQLite 3 and it understands the code for this package, it knows that when you do a SQLite 3 connect to a database file, the data type that's returned is a SQLite 3 connection data type. So it can add this for you. Whereas before, you would have to go up and look into the documentation, the package documentation of SQLite 3 to do this exactly. And the same thing with the cursor. So I do this connection, I get this SQLite 3 connection, and then when I say get the cursor from this connection, it knows from this method, the cursor method, that what comes back is a SQLite 3 cursor object. So that's another use case for this. Here's another application, code editing. So changing simple behavior changes or simple implementation changes are things that LLMs are able to do easily. So here's an example this is from the web security class. This is a way of retrieving sequentially the titles for a list of URLs that you give. So in this case, 2 URLs, and then it calls get sequential on these URLs, and then for each URL, it basically invokes get URL title, which basically sequentially, in a blocking way, does a request for that URL and parses the title out. Now, there's no parallelism or concurrency here. And the problem is that you have two sites that might be in different locations. You should be able to do this in parallel, or at least you should be able to kick off two connections simultaneously and then collect the results. So in 495, 595, it's like, well, it's easy enough to do asynchronous programming on this. And so you make both the get URL title asynchronous, and then the sort of the invocation to try and retrieve all the titles, you make this an asynchronous loop. And then when you say get async both of these URLs, it will kick off both of these things. And then they will gather when the results both come back, then you will gather and return. So you can have the LLM do this translation. They're like, so simple implementation mappings, it's able to do in this case. So let's go back to the password example. You have this terrible insecure password code. Can you ask the LLM to convert it to use a more secure password hash function? And can you ask it to implement the password checking so that it is more secure? And this is why I went with this approach, because the code is small enough that you can see, yes, it is actually doing things with password hashes instead of clear text passwords. And it's basically going to do something more secure. So here's an example where you're taking the clear text. When someone actually enters a password, you're going to create the hash using a secure password hash of the password. And then this is what you're going to return: the salt, the number of iterations, and then the hash itself. And so this is, instead of storing the plain text password, you generate this hash. And then when you're adding a user, given the username and password from the form field, you create the hash password, and then you insert the hash instead of the clear text. So instead of the regular clear text, you're now inserting the hash password. So you should be able to see this and say, yeah, the LLM did good. The LLM was able to hopefully you get your LLM to do this. This is an example that was workable last year. So I'm assuming this is low-hanging fruit for an LLM to do. Okay. And then you have to check that the verification is done correctly. So you get the stored password, which is a hash, the provided password, which is in plain text, and then you take the provided password and you take the hash of it and then see if these two hashes are equal. So again, this is constant time in its runtime, so it doesn't leak any information about the password. It's not storing the password in plain text. It's got all the properties that you want to make a secure password implementation. Now, if your program that you do for this week has a username password sort of feature to it, it better do things securely. Or if you're going to do OAuth, it better use OAuth. I'm not going to even implement the username and password unless I can prompt the thing. But yeah, this is what I'm looking for if you do implement username passwords in your vibe coded application. At a minimum, it should be doing this. Okay, questions? All right, and then the check user is similar. So you basically get the password, and then you invoke this verify password. So that's basically just invoking this thing from the form. Okay, another thing you're going to do is code translation. So how good is it at understanding Python and producing JavaScript? I just threw this in there because it's like, well, you know, LLMs are really good at translating like regular languages. Is it also good at translating programming languages? Turns out not so much, at least not last year. But I'm just going to give it a shot, because you could be asked to take your Python code and like turn it into JavaScript, or to take your JavaScript and turn it into TypeScript. And so these are things that, okay, well, can I trust an LLM to produce code that does this faithfully? And that's what this particular one is doing. So when you ask the LLM to take that Python code and generate JavaScript, it does something that looks like this. And so like, this looks reasonable, but I don't know JavaScript that well. So that's why I just want you to run it. But unless you really know what JavaScript is doing, the validation might be hit or miss on this particular one. Okay, here's another one, regular expression generation. So if you're like me, I was like, every time I look at a regular expression, unless it's super simple, my head explodes. It's like parentheses, backslashes, square brackets, pluses, like dashes. I'm like, I don't know what any of this stuff is. And so you could ask the LLM to produce this. The problem here is that if you already don't understand regular expressions, how are you going to verify that what the LLM produces is accurate? So that's a problem. So you're going to have to almost, supply those tests as part of this is what I am expecting. Moreover, if you don't know all the different forms that the thing that you're trying to match with can take, you're completely insecure. So that's what this example is. So before LLMs, so all of these firewall filtering rules and all of these sort of antivirus signatures, they're all using regular expressions, trying to match a payload that they think an adversary is using. So one of the examples that I like to give is SSRFs. So SSRFs are like web proxies that take in a URL and then they access that URL on behalf of the user who sent the URL. Now, if the URL that is being asked for this web proxy to retrieve is localhost 127.0.0.1, that's a security vulnerability because localhost is typically for services that are on the proxy that should only be accessed by processes on that machine. So this is the canonical SSRF checker. And so if you are asking for a regular expression, what do the following have in common? What are these four fields encoding? Anybody? What do they all share? Very close. So I primed the prompt. These are all localhost SSRF payloads. And you're looking at that and you're like, well, if I made the regex 127.0.0.1, that would have gotten that one thing, but it wouldn't have gotten any of these, right? So it was like you ping this integer, and this is basically if you take 127.0.0.1 as a 32-bit integer, you parse that into a 30-bit, that's what this number is. So this is 127.0.0.1. If you take this hexadecimal 7F12AB34, it turns out 127.0.0.0/8, all of those addresses go back to localhost. So you need your regex to catch all forms of that. But here's where you needed the human intelligence to know that that's what you're checking for. So in this case, this is part of the block 127.0.0.0/8. but it's some random number in there. And so you would have to filter that out. Like if someone gave you this as an SSRF URL, you'd be like, that's localhost. I'm going to deny it. But you have to know that, and you have to prompt the LLM. You have to, like, so yeah, if you're building an SSRF filter application this week, you would want to make sure that you do this correctly. And actually, the lab shows you how to do this correctly. And then here's another one. This is octal. So IP addresses can take octal, they can take hexadecimal. You can just give it a straight up integer that when it gets represented in binary is the IP address. So this is also, well, this is 127.0.0.42. And then this last one, 127 dot this integer is 255, 255, 254. So, okay. Questions about the regular expression one? So I'm not gonna give you the punchline. You do the lab, and then you'll realize, then you'll ask the LLM, and the LLM's smart. It's like, you're like, how do I fix this? Like, what do I do? And it'll tell you what to do. And it won't be a regular expression, as it turns out. It's like, but you have to like know that the regular expression is not what you want for this. You need something else, and I don't want to give it away. Okay. Some other examples. So most of those that I just showed you, you're actually going to do. I want you to just see it. But there's some other things here that the labs were kind of getting long, and I wanted you to spend time using a coding agent more than doing these things. But if you're in the web and cloud security class, we talk a lot about sanitizing the input because the adversary controls it. This is where cross-site scripting vulnerabilities happen, SQL injection happens, command injection. And so one of the things that you could ask the LLM to do is to take the adversarial input and basically filter out any attacks. This is what a web application firewall does. It basically takes the user content, looks at it, and if it looks like an attack, it drops it. Or you could sanitize it sort of like get rid of all the control characters and then pass it along to the web app, either of those two. So these are all the input sources the adversary might control: the URL parameter, form data, any of the headers, the HTTP headers, the user agent header, the cookie header. And then these are places where if they were able to take these sources and inject it into these sinks, you could get code execution or injection to happen. And then what you're asking the LLM to do, what you can ask the LLM to do, is to try and take this input data and make sure you have prevented these particular attacks. Okay, so for example, you can ask the LLM to encode or filter input so that you don't get command injection, cross-site scripting, or any of these injection vulnerabilities from before. So here's an example for the Linux command interpreter. So let's say in your program, you do OS system echo user input, which is bad. It's like, what happens if the user input is hello, semicolon, rm-rf? Then you basically echo the hello and you delete the files in this directory with this OS system command, because this thing gets dropped right in directly. But then you ask an LLM, it's like, well, what can I do to make sure code this isn't vulnerable to command injection? And then the LLM's like, well, you could do this shell escape library. And then what this will do is it'll quote out this user input so that it's innocuous. So then what you do is you sanitize this using this particular package, and then you would get this quoted out so that this is treated as a string. And then all of this OS system does is basically echoes that string with the rm-rf, and you don't get injection. So again, this is something you would hopefully, unless you're really good at input if you've done this for a living, then maybe you know exactly what to do. But for most of us, it's like, well, I don't know how to HTML sanitize. Like, there's got to be someone who has solved this problem, and the LM will point you to the library that solved the problem, and then you would use that. Okay, so I took these examples because this is what I had to do at the beginning of this quarter, and I'm still doing it now because like halfway through the quarter, the stuff that I fixed at the beginning of the quarter is breaking. So here's an example. I had this chat bot that I was using in LangChain, and it broke. It's like, oh, this stuff no longer exists. They deprecated a whole bunch of these things. And I'm like, I'm not gonna look at the LangChain documentation because it's like spread out and it's a painful read. Is it like, and because it's now, there's so many different versions that you have to figure out which version it is that you've installed. And some of you have already come across this. It's like, well, the version on Cloud Shell is like 8 months old. And your examples, which I tested on the Kali VM, which is like weeks old, don't work on it. This is, yeah. Oh, yeah?
Interact with their documentation and ask it for like one like a custom tag.
Oh, wow.
And then they updated their documentation. They made it available in MCP server. But now I don't even see that anymore.
Oh, boo.
Why they just like
well, I'm using ChatGPT because maybe there's some hidden internal MCP server that ChatGPT has access to that it's calling that. But I was like, okay, help me out with this. And then it's giving me the whole history of this thing. It's saying, oh yeah, that thing got deprecated. We got rid of that because now it's like we don't want the user to manually have to bring a buffer. Like that's code that everybody is writing that we no longer want them to write. We want to be concise. So, but like my old code had it in there, and so then it's like, oh yeah, you do these things. And I had an agent executor on one of my agents, and I'm like, oh yeah, we got rid of that because then it just removes one line of code. It's like all agents need to be able to execute. It's like it's silly to have these two things separate, which is what I had because that was the initial pattern. And then so this is something that now I can offer this course with a lot lower stress level, knowing that okay, I'm not stuck with 3 hours of Stack Overflow and LangChain navigation. If I can get a reliable, a semi-reliable way of updating the code without too much of a problem. So then this was just, I threw this in there just because it was something that I came with. So here's another one. So LangChain agent. If you look at this, it used to be, where was this? yeah, you used to have a separate agent and agent executor. It turns out they got rid of that. So now you can just, the agent is a runnable and you just invoke the agent when you do a create agent. So that's something that changed. And it tells you, this is one that people came across. It's like, oh yeah, so it was regular LangChain, and then they had, from LangChain, it was Hub, and then they were like, okay, let's like make it LangChain Classic. And then we're like, well, let's deprecate LangChain Classic and go back to something different. So it changed 3 times. And then like, I have no idea where all this stuff is, but here, ChatGPT, tell me what to do now. And then it's happy to do this. So yeah, this is, in fact, actually, this is out of date. This is not valid anymore, agent executor. So this is actually an old screenshot. They're deprecating that. Okay. The last one is at Google. So we saw like 5% of the issues resulted in successful code patches on GitHub. Google is trying to do the same thing. It's trying to fuzz all of your implementations, get the errors, and then automatically generate the patch. And that's basically, they got up to 15% of targeted bugs. So it did get, this is from, oh wait, this is old also, 2024. It might actually be much better than 15%. But anyway, it's not 100% yet. Otherwise, I'd be saying something. Okay, so that's all the code generation stuff. Most of the time I want you to spend this week on coding agents. If you have used a coding agent already, there are some limitations with generating code with an agent. Some of the things are endemic to the model. So for example, large distances within a code base in terms of, you know, the symbols that are where they're defined and where they're used. Long distances are really awful for an LLM. So this attention mechanism that the LLM uses is an n squared property, where the bigger the n is, the worse it gets as a quadratic function. And so you'll see LLMs struggle when they're manipulating large code bases, and they also struggle with obscure programming languages. So if you're using a programming language that hasn't gotten a lot of training data, it might produce inappropriate code. Okay, so one of the issues with LLMs for code generation is the tokenizer. So one of the things that they found was, well, you have a tokenizer that is meant for natural language, and you're just running code at it, and it's doing things like creating separate tokens for every blank space. And if you realize that the semantic value of a programming language sort of, I guess, the constructs in a programming language are different than natural language, you realize that a purpose-built model that has a tokenizer that's targeting code is going to perform better. And that's where things like Codex, which is a coding-specific model, is using a tokenizer that is more aligned, taking all of those blank spaces as a single token. So that's the indentation. So here's the code. So you have a definition, and then after the semicolon, you have blank space as the indent. So you would want that blank space, the spaces for this indent to be 1 token. And then maybe if there was another indentation, that would be 2 tokens. So especially if it's like a 4 space, like the convention is 4 spaces for an indent. Yeah, you'd want chunks of 4 blank spaces to be a token in order to get better understanding from the model. And that's what this codex is showing you. It's actually taking that block. Whereas just a regular GPT text model is doing like every single space is a token. And then this degrades the performance of the model when it comes to understanding code and producing it. Okay, another issue is the context size. So again, large code bases with complex code, it's difficult for the LLM to be able to reason about these large code bases. And then the training data, it's basically auto-completing rather than doing any reasoning about the code itself, the semantic reasoning. So fixing bugs and adding comments is typically what it's being used for, rather than really manipulating the architecture of code. And so if you want to target coding agents, the application of doing a production coding agent like we saw Anthropic wanted to do, you have to do something else. And so this motivates the use of additional data structures that allow you to massage the code base that you're working with so that the LLM has a more efficient way of understanding what you're sort of manipulating, the code base that you're manipulating. So I'm going to talk about this thing called tree sitter. Basically, and so this is something that maybe not every coding agent is using, but the idea behind tree sitter is being used across the board. And the idea here is that you want to represent your code base at a higher level, at a level that's architectural and not syntactical. So that's what tree sitter is doing. It's a parser generator, and it basically builds a syntax tree from the code. And it allows you to then reduce the context size of all of the different code that you're running so that you represent your code base in sort of a reduced sort of higher level view, which is what you see on the right. So you have flat code, and then it generates this structure, and then it asks the model to reason about the structure rather than reason about the actual tokens directly. Okay, so here's an example of the demo Python notebook. It's doing lexical analysis and syntax analysis and is generating the syntax tree. That's why they call it the tree sitter. And then this is something that the model has a better ability to process and understand. Yeah. Yeah. So one of the things, so Amita, who's the LLM expert in this department, she's like, it turns out LLMs are actually like, you can tune them so that they're better at understanding JSON or understanding graphs more than natural language. There's nothing endemic in the model that doesn't allow it to do something like this better. So she was like, yeah, if you can speak to your model in JSON, it actually is better because there's like more clear delineation of the data you're prompting it with, which makes sense. Okay, so I go through all of that because this is all of this stuff underneath. I'm not going to talk about how it works, but know that when you are using a coding agent, that's the kind of thing it's doing underneath to allow you to get the results that you're gonna see when you build your application with a coding agent. So the first coding agent I'm going to have you do is this tool called Aider, and this is all command line driven. So you interact and generate code just through like a chat prompt in this case. So this is it. You directly utilizes tree sitter in order to help it manipulate large code bases, and that's why I mentioned it before. Okay. So it does things like it finds the most essential pieces, and then it makes sure when it tries to select context. So say you prompt the Aider to do a particular operation, it has a ranking for all the code that is the most relevant and the sort of the most important to include in the context to send to the model. Because you don't want to send the entire code base to the model all the time. You need a separate level that does some ranking of the constructs in the program, like based on what you're asking for. This is kind of like a vector database. Based on what your prompt is, it's going to figure out which parts of the code base matter the most. So it's similar to having a RAG, but for your code in this case. And then it just takes those pieces that are most relevant, and then it sends those to the LLM along with the prompt that you're using to ask it to do something. One of the other things that it does is it integrates directly with Git. So last time when I offered this, I was like, yeah, put this in your Git repository. Like as you are developing it, turn on Git commits, automatic Git commits, and then every prompt turns into a Git commit that you can then push into the repository or undo. And so this is initially what I had students do, is to just do this command line code generation. But I think we're in the age where everyone's doing these coding agents through IDEs. So now I'm like, okay, I'll do something else. But Aider allows you to make every prompt turn into a Git commit that you can then push into your repository. And that's what I'm gonna have you do this on just a regular Git Git repository, not your course one. Okay, here's an example. I create Aider demo.py, add a name parameter to the greeting function, and it goes and it creates the changes, and it does a Git commit. So you see the diff, and it's like, oh yeah, add the types. So it's doing the type annotation in this particular one. So I'll let it play again. It's basically adding a type annotation and then adding a name parameter to the function. So you see the no parameter and then with a parameter and the type annotation after the code. And that turns into a Git commit that you can just push into your repository incrementally. Okay, so that's what I'm gonna have you do. So in the lab, you're gonna do these things incrementally. You're gonna incrementally develop a web application and then incrementally develop a polymorphic ransomware program using the prompts that I'm gonna give you. So then this is just to bootstrap you into the kinds of, like, if you've never used a coding agent before, this is your bootstrap. These are recipes for you to run. Here are some basic commands. So Aider allows you to bring your own model to the CLI. So, you could use Claude Opus if you have a paid Claude account. That's typically what people are using now. It's like the best one. But we got Gemini. I haven't used Gemini 3 for code production, but that would probably be the best one. For this week, I think Gemini 3 is probably your best bet. Although usage-wise, someone was saying that usage of Gemini is hit or miss during the day. Yeah, just to play it by ear. You can have multiple, so I'm going to go through the different modes. You could do architect mode, which is like, I'm going to specify things at the highest level, or you can do code mode, which is not shown here, which is like giving the LLM very specific things to do with your code base. So architect mode is, you would typically start with architect mode saying, this is the kind of app I want, this is what I want you to implement, and then it would do all of that stuff. And then code mode is that if it didn't quite get certain things right, then you could go into code mode and do incremental changes using natural language. Some people are just more comfortable with just saying, I'm just going to do code mode all the way. And then just say, implement this, 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 and this, and then it eventually gets the larger application. Let's see, if you want to, so the model of Aider is that you can, when it produces files, you can add it into your workspace, which can then be used to commit it into a repository is typically what it does. Or you can remove files that have been created and then list the files that are in your chat. So it's all chat-based. It's accumulating all the files in your chat session. And then you just say, yeah, push this all into the Git repository with these files. So then code mode is /code, and then you have these Git commands that you can directly invoke from the chat. Okay, what else is here? Run and test. So yeah, unit tests. If you've created unit tests, then you can invoke the unit tests, and then you can run your program directly from the chat interface rather than exiting out and running the program separately. So you're going to test all of this stuff out, and if you really like CLI-based coding agents, then you're more than welcome to just use this for your homework. Okay, so here's an example, architect mode, and it's specifying everything. I need an MVC app, I need Flask to be used, I need Jinja 2 templates, I need you to listen on, does it say? No, I need you to use SQLite 3, you're implementing a workout fitness tracker. So this is an example, I think this came from like last year, is like a full-on description of the application that you want and all the components. Now, it doesn't say make sure it's not vulnerable to injection attacks, but you could probably add that because it's got a database backend. So make sure that all the database accesses are done with parameterized queries, or that's what I'm looking for in your screencast. It like didn't make this particular screencast, but like this particular script, but that's the idea of putting security concerns in the original prompt, because if you don't ask for it, it's not going to get implemented. Okay, and then save the files, and then create a requirements file so that all these packages can get included, and then you can install the dependencies and then run the code with the chatbot. So all done in a chat interface, and you could just try this out. You just replay these things in Aider and then see what it produces. Okay, here's another one. This is code mode, where you're basically going from the ground up. You're saying, I know exactly what I want to implement piece by piece, and I'm going to give you the pieces. So the LLM is really good at this because you're going right down into the details, specifically asking for basic components. So basic Flask app that has a route for the home page that renders index.html. Super simple. And then you build it up. You're like, okay, set up the landing page with 3 sections, upload embed, and download. So this is a steganography hiding tool. So you give it an image and it'll use steganography to encode a message inside of it. So this is a student project. And then they run it, and it's like, hey, I can't access this page. Can you actually include an app.run? So in this particular interaction, the LLM didn't know how to kick off the server. It'll probably build this correctly this time, but then this student was like, so couldn't get this LLM to do it correctly, so actually had to specify this. So this is a little bit of cheating. I told the students not to write a line of code, but they wrote the line of code in a prompt. So I guess, like, all right, you can do that if you want, but the idea is to not have to do this. So yeah, I don't really want you to actually edit code or produce a line of code this particular week. And then in the upload section, I want to tell you exactly, you need a button, select a file, choose a file, and then hit the upload button. Then implement the app to handle the image upload, save the image, and then display it. And then on and on. So I'm going to walk through this thing. So then has this detailed script, step-by-step instructions, and was able to replay this. Here's another example. This is a mixed example. You start with architect mode. And so you're like, Python web app, that's a RAG application, listens on port 5000, does something with OWASP's top 10 web vulnerabilities, and it implements something. And then you're like, install the dependencies. And then you're like, well, I need to change something. And this is where you're like, that code that you have, just modify it so that that function that you implemented, get RAG response, has something like calls Google Generative AI as its model. And then it would go there and patch that thing in your code. If you didn't like what it did, you can undo it. And then you say, okay, do something different with your application. Okay. And then this is just another, this is just part of the script that the student used, and is just trying to incrementally add things to this application. Change, so this is a Streamlit web app. So I think you use Chainlit. So the idea was to do an interactive RAG application that had Streamlit, which is a similar chat interface, and then retrieve the RAG from OWASP's top 10. And so this was the script that they used to build this thing. Okay. All right. So one of the things that you want to do is pick an LLM that you're going to use for the week, and hopefully it's reliable and has resources to run. So every model has different performance on different languages. Depends on what they use as the training data. So it does pay to go and look at the benchmarks. I mean, we're all doing Python code here, so it's like, who's the best at, oh, it's not on this benchmark. Who's the best at Python? And you're like, okay, well, I'm going to pick that model. Even across Google's Gemini, I think Gemini also has some coding specific benchmarks, and you can see which model does the best out of its coding benchmarks. Okay. Aider, actually, this is what you would want to do. You go into the Aider benchmark, and then you look for the model. And so this is super old, but like if you go to the leaderboard, do I have a link to that? I don't know if this is a link. I don't think it's changed. Oh yeah. Yeah, go to Aider chat docs leaderboards, and then this should be up to date. And then you pick the model that generates the best code. I don't know if they've broken it down based on the programming language, but it's a pretty good rule of thumb for you to get your stuff working. So here's an example. This is where you're like, oh, wait, where's Gemini? And it's not on the list. And sorry, you get what you pay for. So we're not really paying for Gemini. So that's what we're left with. But some of you, if you do have an account on some of these other ones, you're more than welcome to use them. If you have Claude Code, you're more than welcome to use it. I don't have Claude Code, but I'm thinking about paying for it if I'm reading the marketing and believing it. I think I might have to. Yeah. No, you can use anything. So that's what this is. I give you scripts to use for Aider, and then GitHub Copilot and Cursor this was over the summer. I developed this thinking that those would be the ones that I would have people use, but then really Claude Code. I don't have a Claude Code account, but I know a lot of people are using that. So you can choose whatever it is. But the idea is that to not manually write a single line of code this week is the, but if you have to say, do an app dot, if you have to do the app dot run thing, you have to do it. But I would suspect most models, you won't need to do that. I put this line of code in here as a prompt. Hopefully that doesn't show up, but if, every time I run this, I don't know. So yeah, the big thing is, and this is, so I changed it. It used to be I had everyone use Aider, and then the git commits from Aider, I saw the prompt, because every time Aider did a commit, it gave you the prompt that generated the file, and I'm like, oh, sweet, I can actually replay. This is how I got those traces. It's like, oh, well, this student's homework this week was that, and so I was like, okay, well, this is, now I know the incremental development process that was used to vibe code the app. So now I think it's actually better that you rehearse and fine tune the script, because I got a lot of undos and a lot of like stuff that didn't work as part of the git commit history, and I actually had to whittle that down. But now I think the idea, at least what I'm having you do, is to actually, you have a particular application you build, and you're going to build it all kinds of ways with prompting the first time, and then you're going to be like, well, if I could just build this with one prompt that reliably works, what would it be? And so by the process of you whittling it down so you can produce your application in 5 minutes with just natural language, you will get really good at using a coding agent. That's my theory. Like, I will hopefully see some applications that can be built with one big prompt, but that's going to take a lot of work between you and the LLM. And so I would recommend not biting off an enormous application to build, but to a reasonable application, and then just try and get a single prompt to implement it pretty deterministically. And then maybe if you have that working, maybe you can do some add-ons and then see if you can get a single prompt to do this add-on with the original. So I would be more constructivist on your homework this week. Start with the simple ones that you can hit with one prompt, and then just keep adding, and then see if you can keep that one prompt, or maybe 2 or 3, depending on how you interact with the coding agent. Okay, so yeah, you're gonna replay those prompts in 5 minutes to go from 0 to a functioning application with natural language. I mean, you're gonna copy and paste, and then pause the recording as the generation happens. You don't need to, that time doesn't count as part of your 5 minutes. But then, yeah, show me a functioning app with natural language in 5 minutes would be your homework for this week. Questions? All right. Yep. You do not have to do a walkthrough of the code. Well, you should show me the code that's generated from your prompt. I should see that being produced. There's not enough time for you to necessarily do a source code walkthrough. But I do, out of force of habit, I do want you to actually believe that the code that you produced actually does what it intended. I think just by having a functioning application, you have to have gotten it correct at least. So yeah. Any other questions with the assignment? Yeah. No, I'm leaving it up to you. Copilot, Cursor, Claude Code, anti-gravity. Although anti-gravity, like whenever you ask it something, it just gives you TypeScript. So like, yeah, that one, unless you know TypeScript or JavaScript, I would recommend not using anti-gravity. But yeah, Copilot, Cursor, or Claude Code, or you could just use Aider. Aider is fine. Like some of those, that's why I showed you the Aider prompts. It's going to do something similar, but without the UI. So yeah, interactively. I didn't want to mandate people. Well, I think as students, you get free GitHub Copilot, right? Yeah, so this is actually free. Cursor, I think, has a free tier, right? So this is why I picked these two things. Yeah.
Models. It's interesting because you won't know what
model being used for your product?
It's probably the cheapest one. Yeah, the cheapest one at the time. All right, so I don't recommend Cursor. I don't recommend anti-gravity or Cursor, and this is me trying to help you out, not trying to like. But like GitHub Copilot, I think is what that's free, and it's pretty. It gets you off of the Gemini stuff if you really feel like the Gemini stuff is not producing code. You know, you can switch at like you could try it out at the beginning a little bit, and then before you commit to the actual application, just to get a feel for what these models are doing. And feel free to share. Like if you come across benchmarks, just share them on the channel. And like I didn't have time to look up the leaderboard, but you could go ahead and look at the Aider chat. So the Aider chat is really good at it's very specifically benchmarking what it's trying to do. So this is where you would go to the Aider benchmarks versus just the regular benchmarks on Hugging Face, because it's like Aider is, you know, purpose built for just code production. So that's where I would like, yeah, look at its leaderboard and if you're especially if you're using Aider, and then use the model that that you see is good from that leaderboard. Okay, so yeah, the rest of the time, have you start the labs and then get to the homework.
Oh, was there a sign-in sheet there?
Oh yeah, sign-in sheet. Sorry. Yep. Passing around.